G'day again. Back to question 12. A, B and C are on the circumference of a circle, centre O, which lies on BD. AC intersects BD at Y. The tangent D passes through X, and they give you this nice diagram. They tell you given CYB equals 100. And they also tell you it's given that DCY equals 30. So because of the diagram, it actually looks a bit confusing, but if you know your circle rules, it's very straightforward. Let's see how we go. What is the size of angle ACB? So you want ACB. If they'd have given you what is YCB, it sort of gives away what you can do to solve it very, very quickly, in that you've got this triangle here, which is a bit hidden. So if we just redraw it very quickly here, you've got that triangle just there, and now the rule looks obvious. It's passing through the centre. What do you know about the rule passing through a centre of a triangle? Well, you know that that angle is 90 degrees, so it's very easy. If that's 30, you know obviously that's 60, so your answer to 1 is 60 degrees, right? So that's pretty straightforward because of angle in a semicircle. Let's look at the second one. G'day again, back for part 2. What is the size of angle ADX? Now this one should be pretty straightforward and probably the easiest one of these from your circle rules. If you just look at the circle, there's your tangent, and you look at this triangle just there. So just looking at that, just there, you've got that angle there and that angle there, and that's a straightforward circle rule. You know that that equals that, so your answer to part 2 is very easily 30 degrees. The difficulty is in viewing that triangle. So I suggest when you get a question like this, you draw this, you draw each of the triangles separately. So you draw the picture maybe 3 or 4 times. So for question 1, you would have drawn that triangle, then you've drawn that triangle, so you can see each of the triangles separately, and it lays it out for your brain to think, oh, what rule can I apply? Okay, I think that's a much better plan. So let's look at the third one. So if we look at the third one, find giving reasons the size of angle CAB. Now you know already you've labelled that as 30, and you would have labelled this on your diagram as 30, and you've got 2 ways to get to here, and that's the triangle you want. So let's draw that. The first way is straight from there. So if we look at this like that, that's 30, so that's 30. So that's one way you can get that 30. The second way you can get that 30 is straight from here. You don't even need that one. You could have done it from the start of the question, and you could have said, well, I've got this. I've got that 30, and you know angles in the same segment are equal, so that's got to be 30. Okay, so that's 30 and that's 30. A bit more tricky to see the angles in the same segment because of the other lines, but the same, you've still got the rule. So either that's your reason or that's your reason for getting 30 up there. Getting a 80 there is very obvious. I mean, it should be straightforward. That's supplementary. So you've got 80 there with your reason of supplementary, and then you've got 30 up the top with either reason. It doesn't matter which reason you pick. And then your last reason is going to be that plus that equals 180, and you're done. So let's pick 3 reasons. So we'll pick that one first. So you would write BYA equals 80 degrees, supplementary to BYC. Second one, and again take your choice as to which one you want to pick. You could pick that one or that one. Let's pick this one. So angle ABD equals angle ACD, and you've got angles in same segment are equal. And then you've got your last one, which is angles in a triangle. So therefore angle BAC equals 70 degrees. Sum of angles in triangle adds to 180 degrees. And you're done. G'day again, back for 12b. The points P, 2AP, AP squared, and Q, 2AQ, AQ squared, lie on the parabola x squared equals 4AY. The equation of the chord PQ is given by P plus QX minus 2Y minus 2AQ equals 0. And it says do not prove this, which is quite helpful actually. Show that if PQ is a focal chord, then PQ equals minus 1. Now, in extension 1, when they're saying PQ is minus 1, it's very tempting for a student, I think, to look at that and go P times Q equals minus 1. What do I know equals minus 1? Oh, the gradient. So if I have M1 multiplied by M2, that equals minus 1. And it's very easy for a student to think, oh, I've got to find the gradient of this curve and the gradient of, if I put in Q and make it equal to minus 1. Because typically in extension 1, there's tricks that you've got to get used to looking for. Now there, it is possible that they could have been looking for gradients, and in this case they're not. In this case they're looking for you to substitute in the actual point. So what you should have done is, if that is a focal chord, what does that mean? It's passing through the focus. So if we have, well, here's the parabola, and we know the parabola is x squared equals 4ay, so it passes through 0, 0, and it's a straightforward parabola, like that. Okay, and we've got some line passing through it, which actually passes through the focus, so that's the focus right there. Well, what is the focus? Well, in this parabola, the focus is going to be the point 0, A, so that distance there will be A, that will be 0 on the x-axis, so that is the focus, and this point is on this line. So what they want you to do is put this point into this line, and that's it. And then if you solve it, it actually equals minus 1. So let's do that. So you've got P plus Q, or what is x? 0, minus 2, or what is y? A, minus 2A PQ equals 0. So now you get nothing, minus 2A minus 2AP equals 0. So let's put that over the other side. So minus 2A equals 2APQ. Divide both sides by 2A. Let's move it over here. We get minus 1 equals PQ. And look at that, you've actually solved it. But knowing to do that is the trick, because extension 1, typically, they're throwing things at you which, I don't know if they're meant to confuse you, but they certainly do a pretty good job of it. So when you see that, don't necessarily think, I mean, you might look at doing the gradient, but look at other ways where you think, okay, how can I think of this, if this focal chord's there, well then it must pass through the focus, so then I can substitute in. So in this case, that's your answer, but it's extension 1, so be prepared for little challenges along the way. We'll do part 2 in a second. G'day again, back for part 2. If PQ is a focal chord and P has coordinates 8A, 16A, what are the coordinates of Q in terms of A? Now, anytime you get a part 1 and a part 2, or even a part 3 and a part 4 in extension 1, or for that case extension 2, look at this part 1. So whatever this is, you're probably going to use this because they're progressive questions. So whether or not you've been able to show that that's true, look to use that in this question, because that's pretty much how a lot of questions in extension 1 are designed, that they're progressive questions, but there's usually a giveaway. So they don't usually say find out what this is, and if you don't find it out you can't progress. That's given, so therefore it's likely to be used. So really be aware of that, it's very important. If PQ is a focal chord, so they've said use this. See? Focal chord, focal chord. If it is, then use it. P has coordinates of that, so that should ring some sort of bells to say P is that. Oh, P is that. Let's match them up. So that should be your first move. So you should be able to go 2AP squared and just write down what P is, and then just write this straight under it. So that's 8A and that's 16A. And if you go, well, if that's that and that's that, well then what can you wipe out? Well, that equals that, 2 of that, so 2P must equal 8, so therefore P equals 4. And if you solve this one, you end up P equals plus or minus 4, because that must equal that. 16 equals P squared, so in that case P equals plus or minus 4, but the giveaway is that on this side it must be positive 4. So you've got P equals 4. Now use this. Okay, so you keep your eyes open for as soon as you've got a symbol that's the same as what you've used before, use it. So we've got P equals 4, so we're going to write PQ equals minus 1. Put the 4 in, so 4Q equals minus 1, so Q equals minus a quarter. And that would be your first move. Stay alert. What are the coordinates of Q in terms of A? Now it's fairly simple. You're just substituting that into Q and that's your answer, but getting through to this stage is probably the trickiest part. Once you've got there, so Q is 2AP AQ squared, put in your Q, oops, that's a Q, isn't it? Whoopsie, AQ. Okay, so then you get 2A times minus a quarter, A times minus a quarter squared. Simplify, so that equals that, which equals 2 multiplied by minus a quarter, well that's minus a half, so you have minus A on 2, and then minus a quarter multiplied by minus a quarter is 1 on 16, so then you get A on 16, and you're done.